Hello students, good evening to all of you all. Assalamu alaikum. Welcome to the online session. Can you all hear me clearly and see the screen clearly? Am I audible to you all?
Yes, sir.
Okay. So today we are going to the addition of resistors. Already in our theory classes we have completed the resistor part. So we are going to do some calculations related to resistors. So it will be going from the basics. So we know there are three types of resistors: fixed value resistors, variable resistors, and light dependent resistors. Fixed value resistor, the symbol is, these are the two symbols for fixed value resistors. Variable resistor symbol is something like this. There is an arrow in the middle. Light dependent resistor, light is falling on the resistor. That is the symbol for light dependent resistor. Okay, either this symbol or this symbol, both can be used. When you look at the variable resistor, it has three subcategories. Types of variable resistor. First one is rheostat. The other one is pre-adjustment. Next is volume control. So in fixed value, we are unable to change the value of the resistor. Variable resistor, we can change the resistance. The rheostat method, pre-adjustment method, or volume control method, we are able to control the resistance. The other one, light dependent resistors that work with the help of light. When light falls, resistance reduces and the current is allowed to pass. When it is dark, when the light intensity is less, the resistance increases and current does not pass. So that can be used as a automatic on and off switch. So all this we have discussed in our theory classes. Today our main target is combination of resistors, addition of resistors. There are two methods. One is known as series combination. Other one is parallel combination. So, yes, let's move on. First, we'll start with series. It is the easiest. Series combination of resistors is the easiest. So, when you look at a circuit like this, now let's say this is 20 ohm, this is 30 ohm, and this is 60 ohm. The symbol for resistance is ohm. Okay, it's a Greek letter. This is the symbol. Already you all have studied the Ohm's law. According to Ohm's law, the equation is V equals IR. Okay, let's say I want to find the total resistance of this. Let's say this is R1, R2, R3. The method of connecting this is series method. Okay, series means it is connected to the main circuit. Parallel is something like this. One on top of the other. These are parallel methods. So now the given one, it is series. No? So to get the R total, we can use R1 plus R2 plus R3 method. So R total equals R1's value is 20, then 30, then 60 ohm. Directly we can add R total is 110 ohms. Directly we can add it. Now by using the V equals IR equation, I am going to find the current. Normally in the circuit, we say that current passes from plus terminal to the minus terminal. So to push the current, we need a voltage. Okay, battery's voltage. Another name for the battery's voltage is EMF, electromotive force, the force which is pushing the charges. Current symbol is I. So here I am telling you The voltage of the battery is 22 volt. It's 22. It's already given. Now they are telling you to find the current through the whole circuit. So now I can use the equation V equals IR to the whole circuit. Because in certain places we use like at individual points, but here we are going to use it for the whole circuit. So total voltage of the circuit is EMF is 22. Current is unknown. Resistance, total resistance is already found 110. Therefore, current through this circuit is 22 over 110. The answer will be 0.2. You can cut this, you divide it by 11, that will be 2, divide this by 11, it will be 10. 2 over 10 is 0.2 ampere. So remember, this 0.2 ampere will travel through each and every resistors. Because in series, when the circuit is in series, current is same. It's a very important statement. Even in the textbook, it is not given. But in calculations, O-level calculations, past papers, many places, you have to use this concept to get certain answers. So this is very important. Current throughout the series circuit is same, or current is same when the circuit is in series. If it is parallel, current will differ. Okay, but in series, current is same. So individually, if I want to find the voltage of this resistor, for example, I will say this is A, this is B, this is C. So if I want to find the voltage of VA, I can use V equals IR only for that situation. Next, I will do that. For now, take it down. Okay, you can think question is, first question was find total resistance. We have found it. Second one, find total current. We have found that also. So the next question is going to be find voltage of A, voltage of B, and voltage of C. Just the ones who want to take it down, quickly take it down. Others, you all can try VA, VB, and VC. If you all have any doubts, you all can send me a chat box message. Now I am teaching you how to add the series resistors as well as how to find the current in that situation, and by using the current, how to find the individual voltages. Okay, without doing the calculation, if you want to find the current, the equipment we should use is ammeter, and it should be connected in series. So can't we write the answer in fraction? Yes, can write, but here I think we are getting a proper, 0 point proper answer. So you can go for it. So another name for voltage is EMF and potential difference. Is it? Yes, Buddha. The voltage of the battery, okay, voltage of the battery is known as EMF. Voltage within the circuit, for example, this A, if I find the voltage of A, another name for that is potential difference. Yeah, today I didn't give you all the paper. Today I am doing the discussion directly. Actually, in this discussion, you will be learning how to do the calculation? Yeah, someone has said didn't understand how to get the current. Use this equation, V equals IR. Online class students, you all can copy this in your tubes. Physical class students, I have done a lot of questions. If you all have space, you all can copy this, or else you all can copy this in a home. Voltage of the battery 22, current is unknown, resistance value is 110. Then we find I, that is the current. Yeah, there is a question, isn't it 1 over 5? Yeah, 1 over 5 is 0.2, no? Okay, someone is asking how is 1 over 5, 2 over 10 equal? That is basic maths. Balanna, we got 22 over 110, right? Then we cut this with 11 and this with 11, we got 2 over 10. Yeah, someone has got 1 over 5 answer. Yes, that is correct. Now do the long division for 1 over 5. 1 divided by 5. 0. When you put the point, this will become 10. 0.2. I am stopping here because it's easy to get the decimal value whenever there is a denominator 10, 100 or 1000. It's very easy. If it is 2 over 10, it is 0.2. For example, if I say it is 17 over 100, then I can get the answer 0.17. Let's say it is 25 over 100. Rather than going for 1 over 4, I can directly put 0.25. No? So like that, you when doing questions, you will learn more shortcuts. Why I stopped here is because it's easy for me to derive the 0.2 rather than going for the long division. Hope it's clear. Yes, you all can take it out. Yeah, can you all change the equation to V equals Ri? Yes, possible. If your school is Royal Institute, you will easily remember. Hope you all are clear. Yeah, now you all can take a screenshot because I will have to erase one part to do the V equals IR for the smaller circuits. So now I will show you how to find the voltage of A, voltage of B, voltage of C. Voltage of A, voltage of B, voltage of C are also known as potential difference of A, potential difference of B, potential difference of C. So first one, potential difference at A. There I have to use the V equals IR, but at A, V equals IR at A. Yeah, someone has got the answer, but Putha, when you add all your voltage answers, is it coming to the voltage of the battery? If it is not adding to the voltage of the battery, that means your answers are wrong. We'll see how that is done. So I can say this is VA, IA, RA. VA, IA, RA.
So they will give the EMF, right?
Yeah, they have given the EMF 22 here. So voltage of A, to find the voltage only at A, only at this A point, the equipment you are going to use is a voltmeter. But now we don't have a voltmeter, we have to use calculation. So VA equals current through A. From this special concept, we know current throughout the series circuit is same. So what is the current we found? 0.2. Through A also it will be 0.2, B also 0.2, C also 0.2. So 0.2 into RA. What is the resistance of A? 20 ohms. So VA is 4 volt. 0.2 into 20. 0.2 you can think it is 2 over 10, no? Into 20. This 0 will get cut. Answer will be 4. Calculation part you can do it in any method. Harine. Then let's find the potential difference at B.
So what's the meaning of EMF?
Uda, I can't hear you clearly. There also we are going to use the equation V equals IR, not to the full circuit. Potential difference at B. This is only B. Potential difference at B is going to be same equation. V equals IR, VB, IB, RB. Voltage of B equals, current is same now, 0.2 into 30. VB is going to be 0.2 into 30 is 6 volt. What is the meaning of EMF? Electromotive force, EMF. Now let's see what is the voltage around C circuit. I can keep a voltmeter like this and check, or else the calculation V equals IR at C. And then when you multiply, I think you all will get voltage at C is 12. You all do the calculation, you will get 12. Now when I add all these, I have to get a value which is equal to the EMF of the battery.
Wow.
So voltage of A is 4. Voltage of B is 6. Voltage of C is 12. So when I add everything, I'll be getting 22 volt. So that 22 volt is equal to the EMF of the battery. Can you understand? So this is how we do series addition, series calculation. Okay, let's go to parallel addition now. You all can take a screenshot. Yeah, these are the possible questions they might ask in series. Voltage, individual voltage. Current they can't ask individually because current is same. So total current and addition of the resistors. These are compared to the parallel one. This is easy. So let's go to parallel. No current, right? No current passes through it. So balanna parallel. First, I'll just do the addition part. After that, we'll go for the circuit questions. Now, let's say this is R1, R2, R3. I have to get the total of all this. Okay, I have to get the total of this. The concept says the equation is 1 over R total, because you can't directly add this because it is in parallel. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. R3. So let's say this was 10, 20, and 30. Then to get the answer, I have to put like this: 1 over R total equals 1 over 10 plus 1 over 20 plus 1 over 30. Then can I add like this? 10, 20, 30 equals 60. 1, 2, 3 is 3. Totally wrong, no? In maths, if the denominators are different, you can't add it. Then you have to make it equal and then only add it. You have to use the maths part, okay? Don't think maths is only there in maths. Maths is there in science, everywhere. Maths is the basics. So here you have to get the LCM. Most probably it will be 60 in this situation. Then numerator also will be multiplied according to it. 6 plus 3 plus 2. 1 over R total answer is 11 over 16. Still we didn't get the answer because we need to find R total. Then what we can do is, in maths there is something called reciprocal, no? Denominator will become numerator, numerator will become denominator. Then other side also same thing happens. When we take the reciprocal of both sides, 1 over R total will become R total over 1, which is equal to RT. You can just keep it as RT. X over 1 is X, right? RT over 1 is RT. The other side, what will happen? 60 over 11. These kind of fractions, if it is not getting cut, you can keep it as it is. So this is the total resistance in this situation. Yes. Quickly take a screenshot of this. This is the basic part. Once you understand, you all can do it alone. Yeah, if you can calculate the decimal answer, you can go 5 point something. If it is this kind of a one, but if it was 60 over 10, then you can cut it easily and give 6 ohm. Okay. So why did you do the reciprocal? Because we need to get the R total answer, no? Now it is 1 over R total answer. To get the R total answer, you have two methods. You can cross multiply or take reciprocal. Both are same. 1 over R total equals 11 over 60, right? Now, according to maths, you can have many methods. You can cross multiply. 60 will come to this side. Division 60. 60 into 1 equals 11 into R total. Then R total equals 60 into 1 over 11. Then 60 into 1 is 60 over 11 is R total. That is cross multiplying method. 1 over R total equals 11 over 60. Reciprocal method, numerator becomes denominator, this side numerator becomes denominator, and the denominator becomes numerator. Just exchange. R total over 1 equals 60 over 11. R total over 1 is R total because we need the R total value. Hope it's clear. Someone is asking, do you conduct maths classes? No, Puda. There is a better maths teacher. You all know Rizlan sir, right? I think he is currently the one of the best, no? Because yesterday we had the mock exam uh, only for his paper class students. More than 500 participants came. We didn't have a space to keep at the institute. So we had to book a hall at Colombo University and do it. That's why, like, these days the institute was really busy. Yeah, more than 500. I don't know. Probably have to get the count. Someone is saying 1,000. Yeah, we can consider him the goat, no? Yeah. Okay, anyways, there are other teachers. I'm not saying no, but he's doing it in a superb way. Then let's go to this kind of a calculation. Let's say the resistance value is given as 30 ohm, 30 ohm, 30 ohm. How about this calculation? Okay, first you all do the normal method. I will teach you all a easy method. What is the normal method? 1 over R total equals 1 over 30 plus 1 over 30 plus 1 over 30. That is a normal method. No? Then you will get the, now denominators are same. So directly write the denominator, 1 plus 2 plus 3. Sorry, 1 plus 1 plus 1 is 3. R total equals 30 over 3, that is 10 ohm. We got the answer. But in case short method is MCQ, you don't need to do all these things, no? If there are two ifs, if it is parallel and if the parallel values are same, if the resistor values are same, 30, 30, 30, in that kind of a situation, directly you can get R total by using this equation. The resistor value of one resistance, the resistor value of one resistance, divide by number of resistors. Number of resistors. Check this one and see. What is the resistance value of one resistor in this question? 30, 30, 30. No, take one value. 30. How many 30 ohm resistors are there? 1, 2, 3. And are they parallel? Yes. Our condition is fulfilled. No? Parallel and same. Parallel and same. Then 30 divided by 3. Answer is 10 ohm. Directly you got the answer. So when it is parallel and when it is same, use the short method, especially for MCQs. Hope you all are clear about it. Any doubts or any problems, you all can ask me quickly. Okay, then now you all can try a question, a simple question. Okay.
Says this is equation 4.
Sir, did you send a paper? No, today I didn't send a paper, Pudha. I thought of discussing this in class itself. The resistance value of each resistor is 200 ohm. Try this and see. It's 200 ohm. It's very easy. Sometimes even before I complete the circuit, students will sometimes give the answer. Each 200, 200, 200. 200, 200, he also 200, 200, he also 200 ohms. It's very, very easy. Use the short form method, no problem. Yes, many students have got the answer also. Yes, very good. Many have got the answer. So resistance value of each resistor is 200 ohm, right? So first thing what you should do is think. Now there are three different parallel circuits. So if I condense this whole thing into one circuit, one resistor, it will be like this. Then if I condense this into one, it will be like this. And this is directly 200. Here I have to find a value. Here I have to find the value. Balana, 200, let's say this is A part, B part, and C part. A part, you can use the short form. Total resistance is equal to one resistance value divided by number of resistors. R divided by number of resistors. 200 divided by how many resistors? 1, 2, 3, 4, 5. 200 divided by 5 is 40, right? So the whole thing condensed together forms a 40 ohm resistance. Next set, this one. There are two 200 ohm resistors. So they also use the same equation separately. 200 divided by the number of resistors, 1, 2. 200 divided by 2 is 100 ohm. This one directly I can put 200. Now look at the circuit. Now they are not parallel. Now all are series. Directly I can add 40 plus 100 plus 200. Our total will be 340 ohm. Did you all understand this? Good. Take a screenshot. Later you all can do the correction because today I'm doing only 1 hour class. Next week we'll go for another 2 hours. 2 or at least 1.5 hours. Yeah, most probably next week will be our last paper class for the year. Because in December I'm not having any paper classes because school also holidays. Theory class, because in school, in December, our theory class will be our final exams. Can't we take it as 8 resistors? No, Putta. If you look at this, these 5 are parallel separately. These 2 are parallel and this one is separate. So all are not parallel. You can't take it like that. Grade 11 papers will be there. Grade 11 as usual will be due. Grade 10, the free paper class will not be there in December. Again, they will start in January as grade 11 paper classes. Hurry. Look at this question. These are the two main points, X and Y of the circuit. When connecting the circuit is something like this. Try this and see. Find the total resistance R total between X and Y. Yes, some have got the correct answer. Good. Yes, only thing is little bit think that this circuit is in the box pattern. This is coming like this. Think like this, will you? Then okay, no, X and Y. 30 here, 40 here. 20 here, 50 here. These two are in series, right? You can add those two. These two are in series. Now there is no rule that first you have to do the parallel and go to the series. Earlier question, logic is parallel was easy to add first. Add the parallels and finally get the series. Here, series is easy first. Add the series and go to the parallel. That's why here we have to use the logic. You can't memorize. People, that's why many people say electricity lessons are hard and all. That is because they are trying to memorize everything. They try to memorize one equation and do all the question in that same method. Wrong. So here what will happen? I can further make this circuit into a smaller circuit like this. 30 plus 40, 70 ohm. 20 plus 50, 70 ohm. 70, 70, parallel and same. What is our concept? R total equals resistance value of 1 divided by the number of resistors. Here the resistance value is 70, number of resistors are 2, 70 divided by 2 is 35 ohm. This whole circuit finally ends up in 35 ohms. Are you clear about it? YouTube channel link, yes. You all can, there are a lot of physics questions, all my past paper, grade 10 free past paper, we have been doing from, I think, February, March, we started. All the recordings are available in YouTube. My channel is Science Academy, Colombo. Or you just type Science Academy, Rihan Rahim or something, RIHAN in YouTube. You will get all the past grade 10 paper classes. Grade 11 paper classes are paid. That happens every week. That we will start night 8 and goes up till 10, 11 sometimes. Last week we finished at 11. Today we are hoping grade 11 fellows are there, no? Today we are hoping to finish at 11:30. Not 11:30, we'll see. Okay, so that is you all can get from the academy. You all can purchase the classes from the academy. But for the grade 10, it's totally free. The grade 10 papers, you can get it from YouTube. Yes, let's try a different type of question. Now let's say here, this is 70 and this is 30. Try this and see. Are you earning from YouTube? Currently, no, not yet. Because I don't put shorts, no. If you put YouTube shorts only, you can go for the monetization. Before this YouTube shorts, I was able to monetize, but there is some issues with that, so I didn't monetize. So I don't earn from that. So whether you all watch it or not watch it, it's not going to be an issue for me. Only thing is, you all will gain the knowledge. Yes, here we can't use our short form because these are different. So you can go to the old traditional method. 1 over RT equals 1 over RT equals 1 over 70 plus 1 over 30. Then go to the reciprocal. 70 30 reciprocal kiyada 210, no? Because 70 into 3 is 210. 30 into 7 is 210. So here upper part will be 3 plus 7. So you will get the answer 10 over 210. That is the what answer? 1 over R total answer is 10 over 210. Then to find the R total, you get the reciprocal. 210 over 10. 0 and 0 will get cut. Answer is 21. Or else you can use your maths cross multiplication method and also get it. Okay, so this is the long method. I'll give you a short form for this, but there are conditions, there are ifs. It should be parallel if and different, but this is only suitable for two values. Okay, only suitable for two values. Not more than two. So you can use this one. If I consider this as R1 and R2, R1 into R2 divided by R1 plus R2. R1 into R2 multiply and divide by the addition. Shall we try that and see? R1 into R2, 70 into 30 divided by 70 plus 30. What is the answer? 2100, because 7 into 3 is 21 and 2 zeros. 70 plus 100, 70 plus 30 is 100. 2 zeros cut, you got the answer 21. So you can keep it as the next short method to find the total resistance of two parallel and different resistors. Two parallel and different resistors. The conditions are it should be parallel, two parallel, but different. If it is same, we have the easiest method. First short method, if the values are same. If it was 70 70, 70 divided by 2. If it was 30 30, 30 divided by 2. But if it is parallel and different, and if there are only two, easily we can use this method.
மொட்டை அடிக்கிறது ஏற்றம். ரசூலுல்லாஹி ஸல்லல்லாஹு அலைஹி வஸல்லம் முதல் செய்யறதுன்னா மொட்டை ஏற்றம்.
Sometimes we will get hard, like uncalculatable ones. For example, let's say 11 and here it's 6 and let's say here it is 7 and 14. Then first you have to make this circuit shorter. Upper ones are series. Here also series. Series and series can be added, no? 11 plus 6, 17. Bottom one is 7 plus 14, 21. Here, when you do the 1 over R total, it's going to be a big mess. So you get R total 17 into 21 divided by 17 plus 21. You can keep the answer as 17 into 21 divided by 38. No, you can keep the answer like this. Or you can multiply this and get the answer. You don't need to go for the full division part because we are going to get point answers. But if it is like cutting values, the values which are getting cut, then you can 1 minute, give me 1 minute. Okay, no? Yeah, if you use the calculator, you can get the answer. I think you will get a whole answer then. Maybe. Anyways, that is how you do those calculations. So next week we will do calculations like this. Today we did the series one with the current, no? Parallel one we just did the addition. So we will have to do this calculation. Whenever there is a battery, there is a voltage, right? Battery has a voltage, we call it EMF, let's say 200. And let's say the resistance here is 10 ohm. This one is 50 ohm. And this one is 20 ohm. Is it important to keep point value or can we keep it as factors? You can keep it as factors if you are not good. If you are not getting proper, like, cutting answers, you keep it as fractions or decimals. That is easy for you. You won't waste the time. Okay, now here what happens is, Pudha, keep this in mind. I'll give you the concept. Next week I will do calculations related to it. Whenever it is parallel connection and battery is connected to it, parallel and battery is connected to it, then what happens? Battery's voltage is equal throughout. So in parallel, voltage is same. In series, current was same, no? But in parallel, voltage is same, current is different. Now let's say this is A, this is B, and this is C. Voltage of A will be equal to voltage of battery, 200. Voltage of B will be equal to 200 voltage of battery. Voltage of C will be equal to voltage of the battery. So this is how the parallel connection works. Voltage is same. But what about current? The main current, I total, will come like this. And a part of I total will go this way, that is considered as IA. The remaining ones will go, and out of that a part will go to this part, we call it IB. And then the remaining ones will go as IC. Now for example, you can think I total is about 20 cars. In a road, 20 cars are coming. About 5 cars are going into this way, IA. Out of the remaining 15, 2 are going to IB. The remaining ones here, 13 cars are going through IC. And like that only current will be divided according to the resistance. Okay, according to the resistance, current will get divided and go through each circuit. They will be different. But finally when coming, this will get added with this. Then this will get added with this. And when coming back, the total current will come back. Because whatever amount of current which goes from the battery has to come back to the battery, no? Because it is like the rotation. And especially the ones who have not studied the theory part of current electricity, make sure you all study it properly. If you all want, my recordings will be there in the website. you all have to purchase the classes. This month we were doing month of October. October, I mean November, no? November online classes, we started with electricity. So you all can go and check that. When you purchase, you will get the tute also. So it will be really helpful if you all are very weak in this electricity lesson, because in many schools they have made a lot of mistakes, and sometimes lady teachers sometimes have a small hard time explaining current electricity. Sometimes it's like in for men, every day they work with electricity, current, and we know a lot of, like, for us it's sometimes simple things, but for some people they don't know about the current, practical current. So only having the theory knowledge, sometimes it might be hard. So I'm not saying bad or anything. So if you all are having a problem, you all can purchase the classes from the website and watch it. So next week we are going to calculate how to find IA, how to find IB, how to find IC, all those methods, and with that parallel calculation also done. So in the book, in the theory textbook, sometimes only a little bit related to current will be there, but the questions they are asking in the past papers are a little bit advanced. So you should know this current electricity lesson very well. And current electricity, don't think from grade 10 it is done. The main big continuation is there in grade 11. So make sure you all do the grade 10 lessons properly. Here we have only one equation, V equals IR. All the others are resistance addition. I gave you R1 plus R2 plus R3, 1 over R1, 1 over R2, 1 over R3, those ones, and the short methods. But the main equation is V equals IR. But when you go to grade 11, we have P equals IV, E equals PT, E equals VIT, and KWH calculation. All these 4 calculations are there in grade 11. So to get those lessons properly and completely to understand it, your grade 10 basics are important. Okay, so even after your grade 10 third term exams finish in school, it's not time for you all to relax and forget the grade 10. Make sure you use your holidays, December holidays and these November holidays properly. Make use of it and be prepared for your grade 11 lessons. Okay then students, thank you for joining the session. All the best to all of you all. Assalamu alaikum and good day to all of you all. Whatever doubts you have, let's continue next week. Keep your doubts and if possible send it to me through WhatsApp. Next week when starting, I will explain about it. Yeah, grade 11s. In another 10 minutes, we will start the grade 11 classes.
Assalamu alaikum.
Okay, walaikum salam.